everyone, welcome to the maths class. Earlier we have started with the chapter complex numbers. In this chapter we have done our first objective, imaginary numbers. Now today we are going to discuss our second objective, that is Cartesian form of complex number. Now, first question arises, what is complex number? So, first of all, numbers. Now, we have already done that type of numbers in quadratic equation, real numbers and imaginary numbers. So real numbers are in the form of 5, 2, 3, -4, 6, 8 and so on. And these numbers are also called pure real number. Then imaginary numbers. Imaginary numbers are those that are in the form of iota, that are also called pure imaginary. So examples are like 3 iota, -4 iota, 6 iota, 5 iota, etc. So these are real numbers and imaginary numbers. But our question is, what are complex numbers? So complex numbers are summation of real number and imaginary number. That is called complex number. So complex number is denoted by Z. Real number we are going to denote by A and imaginary number by B. With imaginary number iota will come. Then other representation is Z equals to x plus iota y. So x is a real part of complex number and y is imaginary part of complex number. So Z equals to x plus iota y is the Cartesian form of complex number. So our first type is find real and imaginary part from the complex number. For example, Z equals to 3 plus iota 4. So from here, real part of Z is equals to, without iota value is real part and with iota is imaginary part. But in the answer, we are going to write only 4, not iota. Now real part of Z is 3 and imaginary part of Z equals to 4. Other example also, Z equals to 2 minus 3 iota. From here, real part of Z equals to 2 and imaginary part of Z equals to -3 because our general form is with plus sign. So here imaginary part of Z equals to -3. So this is the first type. Now second type is equality of complex numbers. So in equality we are going to take two complex numbers. First one is Z1 equals to A1 plus iota B1 and Z2 equals to A2 plus iota B2. These complex numbers are said to be equal if A1 equals to A2 and B1 equals to B2. Means real part equals to real part of second complex number and imaginary part equals to imaginary part of second number. For example, if x plus iota y equals to 3 plus iota 6 and xy belongs to real number, find the value of x and y. So first of all, write the equation, then equate real and imaginary parts. Then from here, real part of first complex number is x and real part of second complex number is 3. So answer is x equals to 3. And imaginary part of these complex numbers are, from first is y and second is 6. So answer is y equals to 6. Now some more examples related to this topic. If x minus iota y is equals to minus 4 plus 3 iota and xy belongs to R, so find the value of x and y. First write the equation, then equate real and imaginary parts. So from here, real part is x equals to minus 4 and imaginary part with sign minus y is equals to 3. So answer is y equals to minus 3. This is the second example. Now example number 3. If 4x plus iota 3x minus y is equals to 3 plus iota minus 6 and xy belongs to real number, find the value of x and y. So first of all, write the equation, then again equate real and imaginary parts. From here, real part is 4x is equals to 3 and imaginary part is 3x minus y equals to minus 6. So from real part, value of x is equals to 3 upon 4. Now fill the value of x equals to 3 upon 4 in that side. Then after solving this value of y is equals to 33 upon 4. Therefore, x is equals to 3 upon 4 and y equals to 33 upon 4. These are the examples related to the equality of complex number. Now students, you are able to do related sums of this topic. Before starting the worksheet given in SNAP homework, you must go through the links guided in the SNAP homework. Thank you and have a nice day.